All right. Well, great. I love it. Tom, you finish, then you start the recording. I love it. I'm Dwayne Davian. I'm at Astoria Mountain Community College, and I'm going to apologize about something in advance, which is, by the way, in the Phoenix metropolitan area. I'm also our faculty senate president, and I've had fun stuff come up today that unfortunately I'm going to have to. This is scheduled for 2 hours. I'm going to have to drop at one. I apologize in advance, not because I want to leave. I would much rather be here with you guys. Okay. But sometimes the real job, requires me to do something. So what do I do? Well, in my introductory physics class, in particular my calculus-based physics class, um, I build in rocketry a lot of times when I do it as a research component throughout the entire semester. Now, let me start off by saying students are not doing what typically would be called original research, but it's original research to them. Okay, it's something they've never done. They've had to look at a very different way. One of the things I want to make sure if people take away from this session, if nothing else, is that undergraduate research doesn't have to be something that's publishable. It has to be something that the students are researching, trying to figure things out and learn how to do it in things that develop skills they didn't have previously. So, for those of you who don't know me very well, I do high power rocketry as a hobby for myself. And what do I mean by high power rocketry? This is a nozzle from one of my motors. Okay, just to give you an idea of when I say high power rocketry, that's a motor nozzle from one of my personal. Not doing that with the students. But what I do in the calculus-based physics is I build the entire course around how do we actually model a rocket's flight. Okay, because you got kinematics, you got forces, you got drag, you got wind resistance, you've got everything you can imagine. So we're trying to build it and we're building it in pieces. Okay, so the idea is, okay, let's start talking about modeling motion. And as part of that, they're also then writing code using VPython, okay, to be able to model that and completely build it. So the first, model of the rocket is just a little rocket going up, okay, no air resistance, just a constant thrust, right? Everybody with me. So building the kinematics, a little bit of that. And then we keep adding pieces to first that model within VPython, okay? And so, okay, how do you add in resistance? How do you have that the motor turns off after a certain amount of time? How do you deal with when the parachute comes out? Okay, all of these things, how do you build that into code? Because mind you, these students have no coding experience typically. So it is a very robust ability for them to actually build that in, okay, and build that code. Then what happens is we start taking, well, that's great. That's all wonderful. We have this nice constant force from a model rocket engine. That's not how they work. Okay, so then we actually discussed how does a model rocket engine actually work? And we're using little C65s, okay, or C67s, depending on the rocket model. Um, just a little piece of that for you guys are called end burners. What that means is they burn from the bottom up, so the volume that they have to pressurize is actually increasing at a greater rate than the burn surface because the burn surface stays the same, so the thrust varies depending on time in terms of what they're getting. So they actually have to take thrust data using we use vernier force probes to actually do it, and they can actually get a force versus time graph, which kind of looks like this, okay, for it, and then they have to incorporate that into their code. Not just a constant force, but their real force data. They actually have to build their rocket. Okay. Again, I kind of give them some parts, but not a ton. I make them figure it out, build it as they can. I'm making sure it's safe. Again, they've been told to go research. Okay, what is center of pressure? What is center of mass? How are those two related? How do you have to vary those? Okay, and so this is just a continual build through the entire semester. Then they build their rocket, they do their mass, they put it into their VPython. Okay, they kind of do some little hand waving. I'll be fair on that with drag. Okay, in particular the constants out front. The velocity squared, it's nice and easy, but the constants, that's a little harder to figure out. Then we go launch the darn things, and we have little altimeters in them, okay, that actually give us altitude versus time in downloadable data, okay? Why? Why do I want it as downloadable data? Because once they download it, they can actually compare it to what their graphs actually look like from VPython, which is a very eye-opening experience because I said I had a video to share. Let's see if I can get this to come up. This is a student. This is actually from quite a few years ago, but I like sharing this one just because the students' reactions and there's I have it muted because how do I say this nicely? Students are students. And what does that mean? There might be a few words that are probably inappropriate said when they get to see their rocket actually fly. Fly being a relative term. And you can probably guess how this is going to go. So there's their rocket. There's a much younger version of me. Okay. Um, and there's the big field I have around campus that makes it really nice to be able to do such things like this. Okay. So here is their launch. And as you can tell, that's pretty much not what they were hoping for. Okay. Um, so assuming things go well, okay, you can actually get a pretty good agreement between their, at least in general shape, the altitude data from the altimeter that's on board. Mind you, it's a $40 altimeter that we just switch between rockets, and it stores up to 10 runs. So they can just, we literally just clip them from one rocket to the next. Okay. And then they download them all individually at the end. But they kind of compare the shapes. They can, especially during the thrust phase, they can adjust a few things or the coast phase kind of do the adjust their constants to try to make it fit better. And how can they make a more better model of what they're actually doing? Now, again, none of this is original research, but for a student coming into a calculus-based physics class, this is a research project that is much deeper and much richer than they would typically get. Okay. It requires them to try to take real world data, which is ugly, nasty, dirty, and never fun, and match it against a computational model, which is something they'd also have never done. Okay. And it allows them to do so many fun and unique things and enjoy it that I get thrilled watching them. Do they get frustrated? Yes. And anybody will tell you undergraduate research can get frustrating. Okay. Do they get frustrated? They're like, why do I have to do this? Well, you're an engineer. This is what you want to be an engineer. This is what an engineer is going to do. You're going to take real world data. Okay, Chris, real world data is fun. I agree, but they don't. Okay. Okay. Well, they do, but they also realize how dirty it is and how much non-fun it is. Non-fun in their first pass. Hopefully by the end they do it. But what this does is it opens them up to doing things that they wouldn't have normally done. And so almost all my classes, whether it's I'm teaching conceptual physics or whether I'm teaching calculus-based first semester, E&M, third semester, are based around some basic project that they build throughout the entire semester, both the physics knowledge and the ability to match it to it. Sometimes, and I'm going to get off rockets for a minute, sometimes that's just in time. Several years ago, there was an article in the TPT called The Hunt for Red October, okay, where they talked about a magnetohydrodynamic drive and how that works and how you can make one in your lab. Great. I saw that on the January, 2 days before my class started. That's the project. So they actually had to make magnetohydrodynamic drives in our little fish tank and make it work and then do the velocity, figure out how fast, how much force is being put on an average ion, and all kinds of fun-filled things because it works by moving sodium and chloride, okay, with magnets and so on. It was a lot of fun, but it takes time, effort, and patience, okay, if you're doing this in part of a class. And it does mean you have to build some time into things you wouldn't have done otherwise, okay? Because you don't think about it, but simple things that are obvious to us, like if I've got a thrust data time graph, okay? Well, the first one I'll use is when they go put that real force data in to their model, Okay, everybody get what I mean? They're taking the original real force from the motor and putting it into the data. The rocket starts off by initially going backwards, down. Okay, when they actually start running the data. Why? I'm asking that as a question. Why is their rocket going backwards initially?
It's okay to type in the chat your answer.
Or unmute, I don't care. Gravity, well, that's part of it.
It's sitting on the ground.
It's sitting on the ground. You got it. And their model didn't have a normal force in it. And so they start it, the force of the rocket is smaller than gravity, and so their rocket starts going in reverse. Then it has to go forward. How do you fix that? That's a great question to sit and have students ponder. How do they fix that? Well, there's multiple ways you can do that. Okay. And where do they get to? Well, easiest way to fix it is you adjust your time data, your force data, so that the first force data you're using and setting as time equal to 0 is when the force of the motor is equal to the force of gravity, and thus it's 0. And that from then on, because it spikes at the start and is thus going to be positive. Because otherwise they lose about a third of a second of data to your rocket going down and then having to get back up to where it originally started. Okay, so there's all kinds of little complications like this that they're dealing with, that they're investigating, they're playing with, and having to do. Now, I typically do this in groups of 3 or 4 with students, and so my classes are limited to 24. So if I have 24, it's 6 groups of 4, and they're tasked to working together. They get who their group is going to be very early on in the semester, but they're having to work with other groups throughout the semester. In other words, that group they have for their project is not necessarily the group they're working with every class period. But I try to build it in. I try to make it that way. And I will tell you that the students at times are extremely frustrated, extremely well, what's the word I want to use? Spiteful towards me for making them do this. Okay. But in the vast majority in the end come out really enjoying the experience because it makes them do something that in the end they're proud of. And in the end, that's the really powerful piece. Again, nothing in this is original research, but it does train them and get them to the ideas of things that they're going to be able to do. That is my prepared remarks, and I encourage people to do it because I do it within the class, within a project base, in any class. And so I don't know how you guys want to run it. I assume you're going to have everybody do their little intro first before questions, correct?
We can do it that way. Actually, I wasn't going to do it that way.
Okay.
I was going to ask questions at this time. So for everybody at each one of our 3 presentations, there will be a series of questions that we're going to ask just to get their specific answers. Some of these questions will be answered during their presentation, but we'll go over them again just to make sure. If you have questions, either you can speak up or you can type it into chat. Chris is monitoring the chat, and so she'll be sure to bring those up as they are appropriate. So the first 2 questions I'm going to ask Dwayne, he's already answered, but he may want to reiterate. The first one is, how do you define research?
How do I define it? It's anything the students don't already know that they have to go out and collect data, find information about, and put into a cohesive package to actually help answer a question or do something or create something.
And then the second one is, how do you determine what is a feasible project?
The first answer to that is the easier one of the two, because I have 2 answers to that. Number one is you got to do it yourself. Okay. And you have to really honestly ask yourself, okay, how long did it take me? How much struggle did I have versus how much struggle is it going to take somebody who's done, not much physics. Okay. Those would be my two answers to that. And the reality is, if it takes me not including maybe build time of my rocket, but the actual making the computational model, getting the data, putting it all together and doing something with it, more than 30 minutes to 45 minutes, it's probably too long for the students for the full semester.
Okay, Larry asked the question, could you list the projects that you do? And then how about algebra trig-based physics?
Okay, for algebra trig-based, I will say I do in the first semester, I do the exact same one, but with the scaled back in terms of what I expect. Okay, in other words, the computational model is simpler. I provide the thrust curve data kind of pre-helped with them, because I'm not expecting them to think as deep about or have the time to think about as deep about, okay, why is my rocket going backwards in my model? Things like that. Other ones that I do, in whether it's an algebra trig based or calculus based or even conceptual based, is like a solar cooker, okay, including how does that work? In E&M, we do everything from building a hydroelectric power plant to having to run it on our sink in the classroom. By the way, that includes having to build and wind to create their own coils. It's not just, take an electric motor and put a wheel on it. Okay. Had in conceptual physics, for example, one of the things on an E&M, and I will be fair, in conceptual physics, I tend to have smaller scale projects rather than full scale projects for the entire semester. So like an algebra trig, one of them I do is, how's your house wired? Okay. Right? Let's do something practical. It's series and parallel. So I bring in Romex cable that's in your house. I bring in true electrical switches. I bring in true electrical outlets, and let's figure out how our house is wired. Okay. And we actually wire up our house, a couple of rooms with outlets and lights, and then we test it. Okay. Does it work? No, I'm not having them plug it into the wall. Let's be completely fair. We're using 4 D cells connected to the Romex. Okay. Because I like not burning down my physics building. Okay. I do the hydroelectric, the magnetohydrodynamic drive that I mentioned. I do, let's see, what other ones have we done? We've done a linear synchronous motor launched roller coaster. Okay, how do you do if you've ever been on one of these roller coasters that are launched, how do those work? Okay, can you make me one? Okay, by the way, that turns out to be much harder than you think it is, to actually get that to work well. Larry, does that kind of answer your question? I mean, they're all over. I mean, okay.
Dean had a question. Are your classes considered to count as both lecture and lab?
Yes.
And you count the projects as lab activities?
We don't give a separate grade for lecture and lab. It is one grade, and they're an integrated course. So I do have a studio variety. What that means is I have my students for 2 days a week, 3 hours at a time. And that's technically on the books, it's 75 minutes for lecture, 15-minute break, 75 minutes for lab. It's 3 hours. Okay. And the grade for all of this is part of their homework project grade, which is separate from their exams, but it's all lumped together to become a part of their grade. Now, I will tell you, in terms of, as you can guess, based on the one I described for the Rockets, it is a good chunk of that portion of that grade. And there are stepping stones, okay, that they get grades for along the way. What I mean by that is, okay, did you get your rocket in VPython to just do this initially? Okay, then did you get air drag put in, right? So in other words, it's not an all or nothing at the end. They're getting feedback and grading between the beginning and the end as they go.
Okay, Dwayne, I have 3 other questions, which are more general like, but the next question is, how do you convince your administration to support this?
You would have to start off by saying I asked the administration to support this. Since I am doing it inside a class, I really don't ask the administration support, other than when I ask them for permission to go out and use the field to do some of these silly things, or to do some of the other things that we're going to cordon off the field when we're doing our solar cookers. Okay, because We had a student one time that brought in an old, if you remember the old backyard satellite dishes, he brought one of those that he had laying in his backyard, and that was theirs, and they built it off of that. So we needed storage, but the reality is at this point, administration's kind of like half the time they're coming up and going, oh, you're in Dwayne's physics class. And Owen, who used to be an adjunct for me there, can probably attest that they do kind of sometimes end up around campus doing those things and kind of have a reputation. Okay. But I will say that one of the things that this has done is, and I'm not trying to steal Kendra's thunder, but I'm going to do this a little bit, is it's gotten students interested in doing more. And so one of the things that I have gotten the administration to do is support us by buying us 2 unistellar telescopes. And I have students now doing the citizen science pieces from unistellar. That, in fact, you can actually see one of them right over there in my corner of my office, right there in the backpack. Okay. That did require more convincing from the administration, because now they have to, students have to have access to the telescopes. They have to have places on campus that can go set them up, turn them in, turn them back out. So I have a very supportive administration. The gentleman that was actually a math faculty that hired me is now the president of the college. So I have a very supportive administration, and that really helps. So
Dwayne, Elena has a question. Do you think it will work for scaled down or scaled up classes, say 6 students or 30 students?
the answer is, in some regards, it works better with 6 students, because you have a couple groups, you can have them really working together, bouncing off ideas off each other. The one thing I don't try to do is make this a competition among groups. Okay. I want them to be collaborative each other. I want them to work together. Okay. 30 students, I think is still quite doable, because then that's, it's just a couple more groups. I would probably scale back a little bit the depth of the project if I went to a larger class of 30. Why? 2 reasons. Number one, I want to be able to provide substantive feedback to the students. I want to be able to be there to troubleshoot for them. And the more groups you create, the less time you have to do that.
Another question I have, how do you fund your projects?
Well, the students pay a $20 per student fee into what's called a lab fee here in Maricopa Community College District. And that's every student taking every physics class at EMCC. So the reality is, in what I'm spending for this project, it is not that much money. Okay. It is probably, if I have a class of 24, so you do the math, 24 times 20, it's roughly $500 they've put in. The entire cost of the motors, some of the tubes I provide them, and things like that for this is maybe at $200. So then I still have $300 to help support things like markers and or replacing lab equipment as it breaks. The other advantage we do have, at least in ours, the lab fees, is they roll over year to year. So if I don't spend it all one year, I don't lose it. I can grow it and do these things. So if I have a more expensive project I want to do, I may have to do a cheaper one year, grow the fund, and be able to do something else with it the next year. Not every place is going to have that ability, but we do.
And it sounds like that you also have that the lab fees actually are accessible by you as opposed to going to a general fund for the college.
They do not go to the general fund for the college. They come explicitly to a account for physics only.
The last question I have may not be quite, well, I'll ask it anyway, and you can decide how you want to answer it. How do you recruit students and perpetuate projects?
Well, the reality is the students recruit themselves. What do I mean by that is either they want to take this kind of class and do this, or they'll take a different instructor. Because not all instructors at EMCC are doing a project like this, even though they might be in the same class. I mean, there's 3 of us, there's 3 full-timers. We all teach the calculus-based sequence. So if I'm teaching one of the calculus-based first semesters, I have enough reputation. They know they're going to have to do something like this. They know one of the other instructors isn't going to do something like this. And thus, they kind of recruit with their own feet. I will say it has not hurt my enrollment in terms of students taking my class, which made me happy. But now the sustaining in terms of trying to do the citizen science stuff, I'll leave that to Kendra, but I will say, because we're fresh with it right now, I'm getting more students than I think are probably going to actually follow through. But we'll see how that is in a year and a half, whether we're still maintaining that with the citizen science with the Unistellar. So I blame Kendra and Joe for getting me into that part. So, and Tom to a lesser degree.
Any, well, that's all the questions we have. Are there other questions that people would like to ask of Dwayne and the kind of projects that he does with his classes? If not, Dwayne, thank you, and please stay around as long as you can. So we'd like to go on to the second presenter, and so Wayne, introduce yourself and then tell us about your undergraduate research experiences.
So my name is Wayne Manraken. I teach at Harvard Community College in Maryland. So just because I do a course-based research experience, just because Harvard is the primary educational institution in tertiary in Harvard County, we tend to draw from all throughout the county. So even though it's like a bedroom type place where most of the people commute to like Baltimore and around there, effectively, we tend to get a slightly different population that you typically would at a community college, where it's usually because I taught at another school before, and so effectively the choice of what I chose to do for my research was drawn on from the fact that a lot of these students purposely go there and then they hope to transfer to one of the, well, not hope, they usually transfer to one of the four-year institutions in Maryland. And quite a few of them are looking to get into University of Maryland at College Park. So the choice of me deciding to do a course-based one is based on the fact of the type of students that we get in the college. Okay, so so I'm sharing my screen, so can everybody see it?
I can.
Okay. All right, so I guess it might be better just the other way, actually. All right, so just extending what Dwayne was saying, what exactly is undergraduate research? And so I pulled out the definition from the Council on Undergraduate Research, and in case you're wondering, I do not rigorously read their site. I just decided to go in because I wanted a definition, a formal definition. And so this is their definition here. Maybe I should have italicized it. And you can read it. I'm not going to say it out loud. But they also had like a bunch of principles that they thought that undergraduate research would enhance, and I just pulled out a couple that I thought that were important to me, which is, as you can see it. But basically, what I think I'm trying to achieve in my course is that students get an introduction into research, that it allows them to extend, the skills that they're learning in either in the lecture or the lab class. It does require some independent work on their part. I mean, I'm there to help and mentor them, but effectively it's going to be on them to decide how they want to proceed with the project. And the fourth one is really important to me. Original is not in their formal definition. So the projects that I pick, and I'll describe a couple of them, are really just based on students being able to conduct an investigation that's perhaps at a slightly higher level than what you would typically do for a class, a lab class. So the course I typically do, well, the course I do the cure on is Physics 205, which, excuse me, happens to be the third course in a sequence for the calc-based students. And this is typically a small enrollment class. There's no more than 8 or 9 students in that class because it's kind of weird. Basically, in Maryland, the calculus-based courses are kind of based off of what University of Maryland at College Park does. It's not the only transfer institution, even for the engineers. So there are other institutions like UMBC that only require 2 physics courses. And so students don't necessarily have to do the physics 3 course, only those who are either physics majors, and we typically get 1 or 2 per year, or engineering majors looking to get into College Park. And so that means there's a range of students that are typically going to be doing this course. So what I felt was that picking one project, per course wasn't necessarily the way to go. So I broke it down, and will always break it down into a couple. Now, it's kind of easy for me to do so because, I don't have 20 students or 30 students. So, in my class, for example, of 7 or 8, I can break down 3 projects and the largest group size will be 3. But these were the projects I did in spring 2023. And I was the one that roughly came up with the projects. So I kind of figured out that when I designed what we were going to be doing, that it shouldn't really take the students more than, I say 20 to 30 hours of direct research time. It did vary a little bit. Like, for example, this particular project, the PAHs, didn't take as much lab time. While, this one, for example, the one with the thermal expansion using essentially a Michelson's interferometer took, towards the higher end. But I try to make it so that the projects don't take that much direct lab time. And in terms of what they do outside of there, it's roughly the same amount of time. All right, so students do have to do other labs while they're in Physics 205. It's not that it's the KO is the entire lab component, but I do reduce the amount of labs that we do. And the other reason why I also wanted to do traditional labs is because I wanted to give students enough time at the start that they could pick a project, they could do a little bit of literature research, which has really nothing to necessarily to do with them being in a lab setting at school, and then design an experiment based out of that. And the other thing I wanted to do was because Physics 205 includes optics, I typically do a Michelson's interferometer lab as one of the labs at the start, and so the students who picked that particular project would therefore have experience doing so. All right, and this was the actual design in spring of 2023. These dates I have here are, they're not as specific as that. It was just around there, so I just kept that. But we did have to do students were expected to do presentations at the end. One of them was involved in a poster, which they did at the Maryland Collegiate STEM Conference. That's actually a conference just for 2-year research conducted by community college students and professors too as well, but primarily students. And it's held yearly, and so I use that as a benchmark for where we do our presentation. But they did also do one in class in the final lab day that was meant for themselves, other students, and other faculty from HCC. Okay, and then I have the outcomes listed out here. Basically, all but one of the students completed the course. I mean, the student that withdrew not because of the project, he withdrew because of his performance in the exam, which you could say was, but it had nothing directly to do with the project. But all the other students completely finished the particular project that they had picked. I did actually present on this. So as you notice, I did do a pre-course survey and a post-course survey that was based off of a a set of documents designed by David Lopato at Grinnell College. It's a little bit old at this point, but I adapted it to what I was trying to do at a 2-year institution. This is a 4-year school, so obviously there's a little bit of difference. And this is what the students reported as what they were able to gain during the during the course. A lot of it had to do with interpreting results, doing presentations, and the actual means of doing scientific research. And one thing I kind of glossed over a little bit was that effectively, while I roughly designed the project and provided the literature, they were the one that decided the specific question. So for example, the one project on the falling spheres in a viscous fluid, I basically provided stuff just on drag of an object in a in a fluid, and they were the ones that actually the students who did that particular project were the ones who actually designed it in terms of what exactly they wanted to do, and they actually included the numerical part, probably because they were doing a numerical based course at the same time. And so they were the ones that decided to do the coding to check to see whether or not the experimental data was valid. And by the way, these two photos here, this was at the actual Maryland Collegiate STEM conference, and this was the poster. This particular student is blocking it, but this was the project poster that they had created. All right, and then one of the outcome too as well was for me, because I was able to attend two AAPT conferences and actually present on what happened in the design as well as the implementation of these particular projects. And the students did actually, most of them did actually get into the school and program they wanted to. One student actually got a scholarship actually for UMD. I mean, obviously this wasn't the only thing, but it did help. It was actually a full ride scholarship, so that was pretty impressive. And of course, this here is my poster that I presented at AAPT. And it has continued. So the cure was also conducted by another in spring 2024 pass. I wasn't teaching the class because me and Alejandro, that's the other professor, actually switch which classes we teach. So he taught it in spring 2024, but he also did a cure. And he also, had the students present similarly to the way mines did. All right, so I guess I tried to answer these questions just because, I don't know, maybe I was being a little too thing with it, but I had the document from Christine, and I was like, okay, so I can, probably answer some of these while I was doing the writing up. So there is quite a lot of good stuff that happens, and still, you'd be surprised, are willing to do research. Not all, but quite a few of them are, as long as they recognize that the project isn't going to be super challenging. You really have to design such a way that it is attainable in the time frame that we have, especially in a course, one semester. And secondly, that it's not at a high complexity that they are scratching their heads and wondering, what am I actually doing here? Also, I found that, if you design the projects, and I kind of did this with the one I did in spring 23, that it speaks to their interests, they're kind of motivated to do it. The other thing I took into account was that effectively, if you can use as much of the lab equipment that you already have, that's great. Secondly, nothing's wrong with asking. And one of the cool things was that at the HCC, we have this special funding. It's called the large project funding, and you can apply for it. And it's kind of underused, actually. It's because I've actually applied for it twice, and in both cases I was approved. So the Michelson's interferometer I spoke about, these are kits, and then you also have to, essentially buy an extension to it. But I was able to get that funded. That may or may not be the case at other institutions, but it's definitely true at HCC. One other thing is that I did have one project that was not funded, and I was thinking about a way to get it funded. And one of the students, who happens to be part of the engineering club, and he said that they had gotten stuff funded from the college because he was part of the club. We don't have a physics and astronomy club, so I was like, well, can I start one of those? And then there's an additional source of funding there from the college. It may not be a lot, and it does depend on how much students you have and how much they're willing to do, but it's definitely something that it's possible. And finally, we do have a small engineering department. The good thing is they're with us in what's called our STEM division. And I have a pretty good relationship with the engineering people. So I ask them for stuff that I can use. For example, one of the experiments called for, not the ones I did in terms of the cure, but one I just did in the last semester, just as an additional project, called for us to use a couple high frequency oscilloscopes, which we don't have in the physics lab. But I was able to have it borrowed, from the engineering labs. So obviously the cure model, I think, works well, at least for me, in a small class scenario. Is it possible to do it in a separate course? I don't think that's as easy as it seems. A lot of institutions, kind of have like fixed course transfers. It's very hard to get these transfers done, at least in Maryland. And so it's possible that you may design a course that would have something in it, and then it not get transferred over. So I've either done undergraduate research in terms of a cure, or I've done it in terms of an additional project done outside of class. And of course, looking forward maybe to start a club-based one, like a physics and astronomy club, because then it's possible, to increase the funding, to have more students, and to get them a little bit earlier. I'm not going to restrict it, obviously, to physics majors. We barely graduate 2 or 3 a year, but anyone interested, would be able to join. And so one thing that I thought about in preparation for me doing the KIO and the next time I teach physics 205 was to start the project with my physics 1 students. This is physics 201. And we did a slightly different project where it was more like computer based and more of them like automating data collection in our Michelson's interferometer. And so these are students that were basically at the end of their first year, and then they're moving on to the second year next year. Obviously, they were able to already get a research experience under the belt, and then it becomes a little bit easier for them to work on something in spring when next we have the Physics 205 KIO. All right, so like I said, our dean actually is pretty much motivated to get people in to do undergraduate research. And she's more than willing to support us when it comes to applications for money. Whether or not we get that is a different question. The other thing I've noticed is that if you make it part of a course, there's a little bit more motivation on the college to fund it, because now it becomes part of something that they have to provide. If it's also probably possible, like for example, with the Michelson's interferometer experiment I did this spring with a group, outside of the course, it wasn't actually in the Physics 201 course, it was outside, that they're willing to fund it if, they're building something that's tangible or something that's useful. The one thing I've noticed is that it really is really helpful to to get help from other colleagues. And even the lab support people, they actually have been pretty supportive. Not as much as I would like, but it's again, work in progress. It is something that they don't necessarily have to do. So as much as I can get, I'm pretty helpful with. Of course, in the cure, they are responsible for the actual experiments that we do in the lab. One thing I didn't mention was that how could I do 3 separate experiments in the same lab group? Well, the answer to that is I didn't. It turns out, these students who were working on the microcystin interferometer were working in our closet because it was dark in there. At the same time that this group was working on, the viscosity measurements, the motion of an object in a fluid, different fluids. We just didn't use water, we use oil and so on. They were doing the experiments out in the main lab. This particular student, I actually had to meet with him on Fridays in order to do the experiments. Fridays, by the way, is our non-physics teaching day in general. And so in order for him to actually do his experiment, he had to use a Fourier transform infrared spectroscopy equipment that obviously is not part of physics. It actually was in the chemistry lab. And we actually got one of the the chemistry professors to help us do some of the early experiments, that he could collect data on. Because it turns out that in chemistry, they don't actually have their organic chemistry students actually use the apparatus to collect data. They collect the data for the students, and the students just do the analysis. So the particular student who was in my physics 205 student was probably the only chemistry student that ever used the FTIR. But again, this was done outside of our normal class time. So I had to make time on Friday, in addition to whatever else I had planned, so that I could supervise and help him out. And so it is really helpful to get, help from other people in the, in your college. All right, and then will I continue doing this? Yes, because I don't know if I said this, there's a lot of benefits to me. Basically, even though, you can probably tell I'm a little bit experienced, I did get a 10-year track. This is only my 4th year at this institution, and I did get a 10-year track position. So obviously I have to do a portfolio, and this looks really, really good on my portfolio. So that's part of the reason I'm, I guess, so motivated to get it done. But, I've been really, really pleased, I guess, with what I've been able to achieve. And, the student, the feedback from it has been pretty positive. Even the ones who are not necessarily that sold initially on research, some of them go to like it a little bit. Some still keep their opinion at the end, but that's all part of it. It is true that I think with undergraduate research, especially at the community college, that it is good to get a lot of support, which may or may not be forthcoming. So, for example, I mentioned telescope access here. It turns out that I have a student who's really interested in astrophysics and wants to do an astronomy experiment. And believe it or not, we actually do have a college observatory. It's a pretty old device. I checked it out. It's a Celestron, I believe, from about 15 years ago. Forget the actual model number. I have it written down somewhere. But it turns out that I will not be able to get a key to this particular observatory. I will have to ask public safety to open and close the doors every single time I would need to use this. And it's not just one door. It's like about 6 or 7 doors. And it makes no sense that I will not be granted a key to use it. So I guess they've been supported other ways, but I guess this is more of a public safety issue. So who knows? All right, I think that's about it. I mean,
Well, thank you, Wayne. So I think he pretty much answered all of the questions since he went through them specifically. So I'm not sure I need to ask any of these questions again. So are there any questions from the participants who would like to know more about any of the things that Wayne is doing? And again, you can either ask those or type them into the chat. Okay, if not, we'll have some more time at the end of the presentations where you may want to ask some more general questions. So we'd like to move on to our third presenters and presenter. And so, Kendra, would you please introduce yourself and tell us about your research and experiences with undergraduates?
Sure. My name is Kendra Sibernson, and I teach physics and astronomy at Metro Community College in Omaha, Nebraska. And I've had quite a bit of experience with undergraduate research at the community college level for many years. So I'm going to mention three of the ones that I've done. Shortly after I got here, I was made aware of a program at the University of Nebraska at Lincoln that was offering cosmic ray detectors to any high school that wanted them. And I said, well, can I get one too? And they said, sure. And they gave us a set of 4 large scintillator panels. And I was able to recruit a few students to do a summer project with that. So we went down to Lincoln for a week. We learned about the cosmic ray detectors, brought them back to Metro, and then they spent the rest of the summer doing research projects using that equipment. So they learned how to use this special program that their graduate students had developed, and so it worked out really well. In order to do that, for the students to get some benefit out of it, I developed a class. So I put through the curriculum committee a class on special topics in physics. And it can be any number of credit hours. We're on a quarter system. So it can be like a 1 credit hour lab class. It can be a 5 credit hour lecture class, but it's some special topic in physics. So it's an umbrella thing. So we had the crop class, and then that's how the students took the class that first time. And it was pure research. You know, we had to build the equipment. They had to ask a question like, you know, does it make a difference how far I put the cosmic ray detectors apart? Or if I stack them and I can get coincidences, can I use it as a telescope? Does it make a difference if I go to the west or to the east or north to the south? Does it make a difference if I collect data at night or during the day? And so it was mainly looking at muon rates, and it was like super successful. I think we had 4 or 5 students do that for that first summer, a couple of the second summer. And yeah, so now that I've got that on the books, I've done undergraduate research at Metro several different ways. So with the specific research class, and it doesn't transfer to the universities as a particular class, but they can get a science elective out of it, or it can transfer as a lab class. But we are completely open to what we can do in that. So we set it up for the cosmic ray class. Once that funding ended, my husband and I started doing high altitude ballooning, which is where you take a weather balloon and you attach a string of scientific payloads, experiments. And we've had over 90 successful flights with the high altitude ballooning. So instead of doing, well, I have done that as a particular research class before, but I have incorporated that into my calculus-based physics classes. So kind of taking out 3 of our normal labs, we would have a buildup to a launch. And then the students would have to design scientific payloads to go on this balloon as part of their lab class with the calculus-based physics. And so with those, well, we've done the high altitude ballooning with tons of different types of students. We've done it with middle schoolers, high schoolers, community college, 4-year college, graduate students, general public, you know, and so it's just kind of what level you gear it towards. So with the college students, I give them a list of experiments that we've done before, you know, like maybe you want to change one little variable and see if you get something similar or something different. You know, like I'll say, okay, you might want to say, how does blank change per altitude as we're launching this weather balloon up to about 100,000 feet in the air? And so you get some really great, well, thought processes in developing those scientific inquiry. Asking the questions, I think, is kind of the important thing for the research that we're trying to have them do, because then they start to take ownership of it. They might not know anything about it. And in terms of like middle schoolers doing it, they will say, let's put this marshmallow on there. And that turns out to be a really great experiment, because as it gets higher in the altitude, the marshmallows change with the pressure. And then when they come back down, they shrivel up. And so we've taken videos of that before. And with the college-based folks, oftentimes they will design a circuit, like how does CO2 change as it goes up through the atmosphere. So then they have to get a carbon dioxide sensor and figure out how do I get the data and record it and all of this. So yeah, we've done these sorts of high altitude ballooning experiments many, many times, and I've done them in the class as well as in a normal research type of class. But most recently, my work in the ballooning has come from the eclipses. So, before the 2017 eclipse, which came through Nebraska, we were approached by our NASA Nebraska Space Grant, and they said, do you want to do some ballooning during the eclipse and try and record and send down video footage from the eclipse while the balloon is in the air? And we said, sure. And it turned out to be, this really large national program with NASA where they gave us some equipment and a base station to try and track the balloon as it was going and then transmit data down. So we had a really successful flight in 2017. And I told the person that was the head of the thing, I said, if you ever get the band back together, let me know. And for the eclipses in 2023 and 2024, they got the band back together and said, would you like to lead a team from Nebraska for these eclipses? So I was the lead for the Nebraska eclipse ballooning program. So we got about $50,000 from that national NASA program to take students to the annular eclipse. And we went down to Roswell, New Mexico in October of 2023. And then we went to Carbondale, Illinois for the eclipse in 2024. I see.
I don't know if you want to answer those questions, Kendra.
Yeah, I see Chris's question should show the eclipse ballooning path. Okay, so I just copied and pasted a link. This is my blog. So I have a blog called Near Space Science, and I put all of our stories of our eclipses online. And so if you click that, that will take you to the story of our eclipse in Carbondale. So you'll have to go back if you want to take a look at the one that we did in Roswell, New Mexico. But if you scroll down here, let me go ahead and just share my screen with the eclipses if I can. All right, so this is, yeah, we got to Carbondale, and my problem was, I know that I have my community college students for at most 3 quarters from fall to spring. This was a 2-year run up to the total eclipse. So I knew that I could not do this solely with community college students. So I had to recruit, and then I had to get help from, there's a professor at the University of Nebraska at Omaha who teaches high altitude ballooning in his engineering freshman level classes. And so like we helped train him on how to do the high altitude ballooning. And then in Lincoln, we had a professor there who is the lead of their aerospace club. And so actually we started with maybe even some high schoolers that weren't in college yet, and some community college students and some university students. So we got like 20 people who signed up. I had 15 people take this class that I made online specifically for eclipse ballooning. And it was like 3/4. So they sent us the materials. We had to build the stuff. We had to do the practice flights, test everything, all of this. So for Roswell, we did one balloon flight and it was super successful. The streaming video worked. It was, challenging for the students. And then we got a little cocky and we said, oh, well, let's do 3 balloons during the total eclipse. So one of them was the NASA streaming balloon. That's that first one there, filling the balloon. And then the other 2 were student scientific payloads. So we launched 3 balloons for the total eclipse. This is a picture of another team. This is Hartford, Connecticut, I believe. And this was so big of a project. This is our launch team. And here's, I think, what Chris was asking for. Here you can see all like 30 some balloons, the path, in the path of totality. So it was really an amazing project. We got some images of the sun. Totality was amazing. And I did tell students, I said, my main mission is to make sure that everybody gets to the path of totality and gets home safely and that you experience totality. And we did that. So super proud of that. The students had an amazing time. Here's our selfie during totality. If you get a chance, I won't play it now, but here's the live stream. So we did have some issues with the live stream during totality, but if you fast forward to the 1 hour, 10-minute mark, you will hear the students experience totality. So it gets dark. The students are like, this is the coolest thing I've ever seen. And fortunately, I told my administrators the link and everything, and several of them were watching. And so they were thrilled at the experience by the students. Okay, so what's the typical weight of payload of the balloons? The FAA requires that free floating balloons are less than 12 pounds. So that's our limit for maintaining, this level of launch. So we don't have to contact the FAA, but we do during especially these high profile cases. We file NOTAMs, a notice to air missions, to make sure that they're aware of what we're doing and that they don't shoot down our balloons. Okay, let me go ahead and stop that share. And if you want to go back to the near space science and look at some of our other eclipse ballooning, it's always an adventure. And so I think that's why it's so wonderful for undergraduate research, is because we're taking care of all the hard stuff. Like, we've launched balloons before, we know how to do it, we know how to go find them, but you never know what's going to happen. They might land in a pasture with a mean bull. They might land in government facility where they have to take you, they've got rifles and they have to take you to the thing. And in the Nebraska, it's not so bad because it's probably going to land in a cornfield or a soybean field. And we have the GPS coordinates. And so we go and we pick them up. We have to talk to the landowners and get permission and all of this sort of stuff. Very rarely do they land in trees. We had 2 of them land in trees when we went to Carbondale. And then trying to get them down is always a challenge. But the thing that really excites me about it, well, the students love, you have the countdown, the 5, 4, 3, 2, 1, lift off, and then yay, and everybody's so happy. And then, the excitement of going and getting the stuff, and you never know what's going to happen. And there's always a risk of failure. And, students are somehow always so worried about failure. And, it's a learning experience. With the NASA thing, it was more of an engineering challenge. It's like, here's the equipment, you have to make it work. And we had some science experiment payloads go up, and we did a test and they didn't work. So they had to bring them back and do the iterations, which I think is super important. But once you get that back, then you have this data and it's so rich, and they have to figure out how to analyze it. Real world data. And so that's like super exciting. And then I think that last step is the communication of it. So, students get so worried about doing a poster presentation or talking to somebody about their research, but you have to tell them, you know, nobody knows this project better than you. You're the expert, and usually the people that ask you questions, they're going to be really nice about it. You know, it's like administrators who want you to be successful. So be confident and just tell them what happened. And even if you didn't get any data because something happened, explain why. And, you know, it's just this process, the whole asking a question, doing the experiment, getting the data, analyzing the experiment, and communicating the data. I think that is so perfect. So the high altitude ballooning works in a bunch of different aspects. With the eclipse ballooning, we just had the opportunity to get the funding to travel. So I said, I'm probably never going to do eclipse ballooning again, because the next time it's in the United States is like 20 years from now. And I will probably not be doing high altitude ballooning at that time. Who decides what data are being collected and makes sense of the data, and do students make predictions? So yeah, you know, like that's the hard part, isn't it? Getting them to ask the questions. And so they have to decide what data is being collected, what they're going to study, what they're going to analyze, and then hopefully by that time, you know, they might make a prediction. They don't have to, but, you know, I can say, well, I think this is what's going to happen based on my prior experience, but I don't know. This is your experiment. This is your data. You analyze it and you tell me. So they're making sense of the predictions. I can throw in some additional information if I have it, but yeah, they're the ones who are asking the questions, designing the payloads and sending them up, and perhaps doing different iterations. Okay, so the high altitude ballooning, you know, is great, but it takes a lot to get into it. There's a lot of details. And so, you know, if you're really interested in that, you can contact me and I can help you out. The last thing I wanted to mention was what Dwayne mentioned, and this is using smart scopes for research, astronomy research through citizen science. So I've been working a lot with these. I got this telescope a couple years ago as a part of an astronomy NASA Community College Network is what it originally was called. And I was part of a team of 20 or 25 the first year, and it was a 5-year grant that they got. And I think they're recruiting for the next year. So if you're interested in joining an astronomy community college network, I think they changed the name now, but I think they might be taking applications for the next year. So yeah, they sent me this telescope and I've been using the heck out of it. It's a little smart scope. So originally it was the SETI Institute and the Science Mission Directorate. So I was in the pilot group, 25 community college students, and what they do is they're trying to pair subject matter experts with community college astronomy teachers. So like if you wanted to get somebody who was an expert in the field of supernovae, they can find somebody and have them like zoom into your class. So they sent me this EV scope, and I have 2 of them now. So one is an EV scope 1, and the other one is called an Equinox. So it's the same chip, but it's just doesn't have a an eyepiece on it. Super easy to set up. It uses an app on your phone. It uses the GPS on your phone to determine where it's at on the surface of the Earth. You point it at some area of the sky that's not at the zenith, and it does what's called, well, it orients. It does a field. It looks and it analyzes the stars, and it figures out where it's at in the night sky. So once you've done that, once you've set up the tripod and leveled it and moved it off and done the orientation, which you can do in like about 5 minutes, then it automatically tracks. Then you hit a little button on your phone and you say, go look at M51. And the little telescope will go to that object. And what's really amazing about it is that you hit this magic button. It's called enhanced vision or enhanced views. And it uses a stacking method. So it takes these 4-second images and it gets rid of the background noise. And so it gets darker the object comes out. And I'll tell you, when I first did this in my home in the suburbs of Omaha, in the backyard, I look to the north, and Omaha's to the north, and I can't see hardly any stars at all. It's that bright from the light pollution. And this telescope looked in that direction, and it saw a galaxy. So it saw a galaxy as good as I see it in dark skies with decent telescopes. And so this enhanced view, I think, is a game changer for urban astronomy. So people in cities can do astronomical research using these little telescopes. They can get down to about 17th magnitude. That is incredibly dim. In town, in the middle of a city. So like if you're an astronomer, you know that light pollution is rated on what's called the Bortle scale. So Bortle 1 is like the darkest skies there are. Bortle 9 is like the middle of LA. And the middle of Omaha is like Bortle 8, 9. It's horrible. And I had an undergraduate research student take the telescope and start to do some supernova measurements. And I think that's incredible. So some potential citizen science missions that can be done, ones that I have done or seen done, are planetary defense. So that's looking at the orbit of asteroids. So you just watch it for like 10 minutes, you send in the data. So the citizen science, there's many digital telescopes out there. Some of them are great for astrophotography. Some of them are good for different things, different sizes of objects. I don't think that any of the others can touch Unistellar on citizen science, because they're collecting data from all these telescopes all around the world. They've got a couple thousand people who are taking data and sending it in, or have sent it in, and they're analyzing it. So your student doesn't have to know how to handle FITS files and figuring out magnitudes. You just send in the data, and then they manipulate it and send it back to you. And if you have taken data on something that they publish on, your name gets on it. So I've had my name on several articles now dealing with the citizen science. I've done asteroid occultations. That's where an asteroid passes in front of a star and it blinks out for a short period of time, maybe a couple seconds, and then comes back. We have citizen science doing exoplanet measurements. How amazing is that? So they're like taking Kepler data, and they're watching this star for a couple hours, and just a tiny bit of the brightness dims, and then it comes back out again. So really hard for one telescope to see it, but if you have, say, 4 telescopes around the world looking at it, and you all see that tiny little dip, then you have a solid scientific measurement there, and you are contributing to the known astronomy data worldwide. So cosmic cataclysms, novae and supernovae, comets, and then they actually send out, like, you can look up the ephemeris, that's the the maps in the sky for spacecraft and really fast moving things like satellites. Okay, question, do you bring the telescopes inside, bring them out, weather permitting, or do you have some magic keeping the telescope out to longer time to collect more data? The Unistellar is about 25 pounds with the backpack. So I always bring it in because I don't want to leave it out and have like the sprinklers get it, or, rain go on it. Easy enough to bring in. You have to upload the data. So oftentimes I will just plug it in to charge it up again, and I will attach it to the Wi-Fi, and it will send the data to Unistellar. And what's kind of amazing is, it's still new. So you still feel like you're part of a program that's working on real scientific data. They have some bots. So you upload your data, like overnight, it crunches it, and then it spits out a poster, and it tells you if you saw the thing or not, and like what the magnitude was. And, I think that this is pretty exciting. So my husband and I help run a nonprofit observatory that has students working over the summer on Fridays and Saturday nights. And I told them, every time you have some clear skies and you aren't entertaining guests, take out the EV scope and do a measurement of T Corona Borealis. So this is the Blaze star. This is a star that is predicted to go supernova sometime soon, within the next few months. And I think the person that sees it go off is going to get a lot of recognition. And so there's kind of a competition to try and get as many measurements on this star as you can. So super easy. They set it up, they take a 10-minute measurement, and they are participating in some worldwide science. So it's super exciting. Oops. So just to show you what some of those things look like, this is planetary defense. So I took this measurement. This is 14.3 magnitude. This is a very dim object. It helps refine the orbits. They tell you what the magnitude is. That's the little thing in the middle there. That little line is, this was asteroid Isabella, March 9th to 10th. I took this. So, and then it gives you a light curve down at the bottom. So there's some really interesting science involved in this. Okay, so here, if you're doing an asteroid occultation, you have to, it's like eclipses, you have to be in the path. So like this particular one came right through Omaha. And so you can look and see if you have any occultations. You have to be there specifically. So this one was only a 6-minute observation to see if you see it blink out or not. The error kind of depends on which one they're taking a look at. These are super fun. They're kind of hard to get though. So perhaps unlikely that you would see it. This is the paper that I got for observing asteroid Aoife. And this was my positive occultation. So it's going along. I was watching on the screen. It dipped out of sight for 3 seconds, 3.21 seconds, and it was expected to be 2.6 seconds. And so that tells them that it was either bigger than they thought or it was elongated and going along the long side. But besides me, there was a fellow in Colorado who got it at the same time. So because of that, we took our collective data and sent it to the Occultation Timing Association in Europe. So yeah, this is what it looks like on the little video. They do this video. I've taken out just this section. The star goes away, boop, it comes back, and it helps you determine the size and shape of asteroids. So I think this would be fun for students to try. Here is the JWST, the James Webb Space Telescope that I got. This was Christmas. It was launched Christmas morning, and this was Christmas night that I got it. And here's the video. This is, now let's see, perhaps a few seconds. You can see the little dot moving. So there's the James Webb Space Telescope taken with my little tiny telescope from my backyard in Papillion, Nebraska. Keep watching the dot. And right before it ends, bloop. So it kind of flared up there a second. And we're going, hey, what happened? And so I was talking with, well, it's the president of Unistellar. I'm like, well, why did it flash like that? And we think that it made a maneuver. So it changed its direction. You got a glint of sunlight off of the bottom of the spacecraft, or it's, I don't think the solar panels were out yet. So that went into a poster that they put together for the SPIE, which is an instrumentation program conference. So here's the poster that they had, and here it's talking about the anomaly, like it got really bright there for a second before it went off. And so, yeah, that was my measurement. Citizen scientist Kendra Sibernson detected a flare in the brightness. So yeah, just super fun that you get to be a part of these sorts of things. You know, so there's folks in Japan who are really into the unistellar stuff. There's people in France. Unistellar is a French-based company. Here are, oh, this is a graph of the supernova in the Whirlpool galaxy. Super popular 2023. And mine was one of the earlier measurements there. And also comets. Comets are super easy to look at using the Unistellar telescope. You might not see them. They might be super dim, but they are getting some amazing data. So there's some interesting comets, like there's this one that's going on that has an outburst. This is what the image from the Unistellar looks like. It goes into the gallery on your phone, and you can share that with students. Students can share that with you. The blue thing there is the supernova in the Pinwheel galaxy. Oh, and then here's a map for like exoplanets. If you're in here, you have a good chance of seeing the exoplanets. And this is data from TESS, an object of interest, the transiting exoplanet survey satellite. So these are toughest because they take several hours. So for students, I think that might be the hardest, but might be pretty fun and interesting for them to be a part of that group. And then this is the data that the Unistellar spits out for the exoplanet measurements. So just a relative flux and the light curve, and you can see the data is kind of messy, but the model that they fit to it, you can see the dip. So it is, yeah, just super fun. So I actually have a student who is going to be an undergraduate research student for me in the spring, or I'm sorry, in the fall. She's taking my astronomy class, and she's getting a fellowship from NASA Nebraska Space Grant. And what I'm going to do is I'm just going to have her give her the telescope and say, okay, I expect you to spend about 10 hours a week on this. In the beginning, you just learn how to use the telescope, set it up, learn how to take data, send it in, and then we'll talk about the analysis later. So doing some additional research into maybe comets or supernovae or whatever. And I think it's kind of a turnkey sort of undergraduate research in astronomy. And I think that it's like super exciting. So I'll go ahead and end there and see if anybody has questions.
So Kendra, I did have, you answered most of the questions that we were going to pose, but I did want you to reiterate one last question, which is, how do you recruit students and perpetuate projects?
Okay, so recruitment so I'm kind of an opportunist when it comes to undergraduate research, like in terms of funding and projects and things that I'm interested in. So like this eclipse ballooning thing kind of fell in my lap, and, had to do a lot of work in the logistics of, taking students to another location and all of that. So funding wise, if you hear about a really interesting project and somebody's willing to support you on that, then jump on it. In terms of students, we had to actively recruit between University of Nebraska at Lincoln, University of Nebraska at Omaha, and Metro. We pushed really hard. I put posters up, had notifications, announcements to try and get students involved in that. It's like, all you have to do is sign up. You have to take this class. I got a grant to pay tuition, so you don't have to even pay anything. You just have to participate, and we'll take you to this awesome eclipse, and it'll be a great experience. And even then, it was kind of hard keeping people in the program, because life happens, and sometimes they fall out. When you do it in the classes, you kind of have a captive audience because it's like they're doing that instead of lab stuff. With the student who's going to be starting this fall, so our space grant has fellowship applications every year, but I never know who's going to be in my astronomy class in the fall because they don't sign up until right before. This student was taking another class at Metro, and she just said, I'm really interested in astronomy. Is there like an astronomy club or something? And she sent her to me, and I said, no, we don't have an astronomy club, but I just got an email saying that they extended these deadlines until today for this fellowship. Fill this out, say I'm your mentor, and we'll see what happens. And she got it. So we've got a student who's going to be paid to do research using the Unistellar telescope outside of class. But yeah, I think that's really important, is to get support for the students, because you get students who will do it because they love to do it and they want to do it. But asking them to sacrifice their time and effort, like 10 hours a week or whatever, that's quite a bit for a student who might have another job, or, is dealing with classes or taking care of family. So I think finding that piece of, either getting a fellowship or paying them through some other mechanism. So I did that with a student last year. Is we have a mechanism set up for students to get paid to do math tutoring. And so I just kind of used that template, and I said, okay, I'll give you X amount of dollars a week for doing this telescope thing. And, they're super happy with that.
Thank you. We're going to take the last half hour and just have general questions that you could ask any of the presenters. I'm sorry, Dwayne had to leave, but that you can ask presenters. But before we do that, I would like to remind people that at the end, or whenever, just before you leave, if you would fill out our evaluation. So we have this participant feedback. So you can either do the URL or or scan this and fill out our feedback form. So with that being said, any questions for our presenters, or anything that you would like to add, because you have some undergraduate research experiences that you're doing at your institution? And again, you can either ask the question or type into the chat.
Hi, Tom.
Hi, Libby.
I don't really have a question. I guess I'm perpetually worried that what we do in our classes, like, can it actually count as undergraduates? I know Dwayne and talked a lot about that, like kind of how to define that. So I guess I'm always just kind of perpetually worried, like, that it doesn't really quite cut the bar. But so I don't know. I just wouldn't mind hearing people's feedback on that at some point, but I don't need to take over the question time. I can ask folks later. Dwayne and Wayne. That's why I was having a hard time. Dwayne and Wayne both talked.
I actually have this exact same question, because I do a lot of project-based learning in my classes, but I never felt I could call it undergraduate research, because they weren't, as the one blurb on the slide said, advancing scholarship of what we know. So but it seems like it's not that clear. It seems like a lot of people are doing things that I would consider as projects, but are considered undergraduate research. Or I was just wondering, is there a community consensus on undergraduate research? How can you define it?
Well, I might ask the question, why do you care what you call it? And I don't mean to sound, mean about that, but like, if you call it undergraduate research, like, who's checking that? Are you talking about your administration?
Yes,
Are you talking
yes.
about, okay, so
it is. So undergraduate research means that you're doing something that could conceivably, if it was done, a certain level, it would be publishable research. In other words, it's got to be something that's pushing our knowledge. And I realize what you're doing actually is, but not everybody has access to that kind of a project. So I was just wondering.
Okay, so why would your administration care about why what you're doing is publishable research? Like, what is the end game? Let's say your students did something in your project-based group, and they did a poster, and then you had like something at the end of the year where everybody shares their posters or something. I mean, I would consider that, sharing their science. And
So
so,
I do that, but it's not considered undergraduate research in, you know, if you say something's undergraduate research, you're more likely to get funding from your institution than if you're doing a project in your class. At least
yeah, so I found, because I was like leading some undergraduate research at our community college for a while. And I had several instructors from biology and chemistry, as well as the stuff I was doing in physics, and trying to figure out ways to encourage more of that, just like across the board. And so I don't know. I think that if you talk to like administrators, that they kind of want more of that all across the board, rather than something that has to fit into this template of, like it has to look like a 4-year college lab based research that gets published in these top journals before you consider it undergraduate research. I figure if you have the students asking questions, doing the experiment, getting the data and communicating it, that sounds like undergraduate research to me.
Okay, well, that's good to hear. Thank you.
Well, yeah, I don't know if like that's my definition. Now, I did go to a CUR conference. It was in Nebraska years ago. And I think we spent quite a bit of time talking about what is research and what does it look like. And they were just like, just do it. It's like all these different types, putting it in a class, making a separate class, having it out of class. They really wanted you to like work with the universities. So like, for example, our chemistry folks, well, like nursing and med and chemistry, we have it's UNMC, so it's the University of Nebraska Medical Center. They have labs over there. So we would take our community college students, they would go work in their lab, and then like some of their postdocs would come teach classes for us. So, it doesn't need to be quite so cut and dry, but, these collaborative things and just providing opportunities for students to do this undergraduate research. Maybe they're directing it, maybe you're coming up with these projects ahead of time, and they have to put their own spin on it. But I think kind of this consensus is it's all good. It doesn't have to be what exact, like what you call it isn't so big of a thing, but just doing it.
And kind of echoing Nancy's comment, just in addition to the administration sometimes paying more attention at my school, but the encouraging students to be able to put that into applications for their transfer, right? Or like, and would someone read that on the other end and see that as like a valuable enough experience to be considered like, oh yeah, the student has done some research level work. Like, I think that's kind of for me too, or encouraging them, like how much can they put and say, hey, look, I've done this.
Yeah, so like if your institution has like one of those cure processes, the students, and so they have like funding and stipulations, and then they have to give a presentation at the end, and then there's, the big poster presentation where everybody, the administrators can go and look at it, is great, because then you have that template. But if you don't, then, well, like for example, with the high altitude ballooning, I tell the students to go ahead and say, I did a high altitude balloon project, and here's, we launched this balloon to 100,000 feet, and here's a picture. And, that's just super exciting without like making it be in a sort of box.
So Dean asks, is there some kind of database of places where you could go to look for funding that could be used to pay students for research?
I don't know of any, I'm just speaking from my own experience, having to come up with funding. So like, I'm kind of the head of the department. So I set the budget each year, and I can go ahead and say, I'm putting $2,000 towards undergraduate research. So here's my ballooning supplies for this next year. You know, I can do that. Also, you know, you have the big national grants or whatever, like the eclipse ballooning that we had. Those are harder to get, but my NASA Nebraska space grant is super supportive. You know, so like my administration is pretty supportive. So if I said, hey, I need $5,000 to buy this telescope to do this undergraduate project with some students, I would probably get it because they know, you know, that I have a history of being successful in doing undergraduate research with students. But yeah, our NASA Nebraska space grant is super supportive. And I don't know that I've ever really asked for anything that I haven't gotten. And they are super happy to help community colleges. So like if you're in the STEM field and you haven't talked to your space grant, every state has a space grant, I would talk to them. And if you are like more towards like the chemistry or whatever, there's perhaps some other avenues, but yeah, I would just start looking around. I think it's going to be specific to your location and to what's like really important to the people in your area. So, I mean, nothing to say that if you wanted to, because, you know, I help out with a nonprofit as well, as going to businesses and saying, hey, would you support, like, I'm setting up a science club and we want to do these rockets or this kind of experiment. You might find some people willing to support you that way. In terms of like student payment for doing research, I think you have to look in your own school at what is available. Like I said, I use, they had this, it's called a NOICE grant. I don't know if that's like a national thing, but they said, we'll pay you $15 an hour for 10 hours a week. And, you know, here's the thing. And I'm like, well, let's do that. You know, you got the thing set up. Let's just use that. And they were okay with it because nobody's ever done it before. So why not?
Other questions?
I have
Or
a quick
comments?
question.
Yes.
Oh, and maybe you addressed it because I kind of came in late. But I guess, have you ever had sort of like a gap in your research activities, whether it's like kind of just due to like funding or administrative turnover? Because that's something I've kind of experienced, and you know, sometimes it's kind of hard to kind of get back in, you know, into those activities again. So is that something that any of you have ever kind of experienced?
Yeah. Yeah, with like our cosmic ray observatory project, you know, we kind of had some fits and starts there because they had grant money, and so we used it at that time. And then we had this equipment, so it could be used. And then like a couple years later, somebody said, hey, I'm really interested in doing a research project. And I said, okay, we have this equipment, here's what it is, you know. And so it didn't have to be like streamlined all the way through. It didn't have to be continuous because every student came up with a new experiment that they use that equipment for. You know, like you're doing this experiment, you come in and use it and do that experiment and get your data and analyze it. We have a big biology undergraduate research program going now called CPhages. And so they're kind of tied into like this national group. They take bacteria samples and I think they do DNA analysis. And so what we found to be really hard is our community college students are with us and then they're gone so quickly. You know, that's what I found with the eclipse ballooning is, you know, I have them for a short period of time and then they go off and then I don't have access to them anymore. So when you're designing experiments, you have to come up with something that they can do in these little bite-sized chunks, come up with an answer, you know, do their poster or come up with some kind of analysis. And then maybe later on down the line, another student can either pick it up and complete it or, you know, pick it up and do something slightly different. So you can't do multi-year projects or expect to do them and have the students have a really good experience and be successful, you know. So you kind of have to take these little bite-sized pieces, and I think that mainly comes from the projects that you do. And you kind of have to design it in such a way that it can be done and they can be successful and get a good experience out of it.
And just as a quick follow-up question, if there's time, because of like maybe the nature of like these sort of bite-sized projects, do you sort of select students who have, say, like met a certain set of prerequisites? I'm guessing no, because you kind of mentioned like, having projects for like middle school and, across the board, but
Yeah, no.
yeah.
So it kind of comes down to what are you doing? What do you have time and effort for yourself? Like, because this is usually a little bit out of the purview of your normal teaching. And then for me, like I said, I'm an opportunist. If you find a student who's like, I love astronomy and I want to go into, I'm like, great, you're it. Because I get so few true astronomers and so few physics majors as opposed to the engineering folks. But like, even if you have an engineer, they said, I'm super interested in electrical engineering and I want to study solar panels and da, da, da. I'm like, great, we have this project where you can, look at solar panel efficiency or whatever. And so, it just kind of comes about naturally from the students that I have in the class. But yeah, if you have a big project and you're like actively have to recruit, that's when I had to go to the universities because I couldn't get them all with my community college students.
Thank you.
Other questions or comments? Or experiences?
I have another question. And this is regarding doing research experiences in the classroom. And one thing that there's two areas that I find problematic. One is if I'm doing it within a course, I also have to cover all the things that are important that the students learn in the course, as well as the extra things that they get out of doing a project. And in my class, students pick their own things. Like I don't give them, I kind of set the kind of things they can do, but they choose what they're going to do. And I think from what everything said, it's a very valuable experience to have, but it comes at a price. It comes at a price of class time. I can't just, I'm talking about an introductory class. Half of the class has never had any physics before. I can't just say, oh, do this at home in groups on your own time. It's got to be in class time where I can keep them from going astray, because otherwise they go off on these things that not productive. It takes so much class time, and it seems like the better I get at doing these projects, the less I cover. And you might say, oh, coverage doesn't matter, but it does in some, so I have this problem and I don't know quite. And I thought, oh, I'll build all the content in the project, and it's easy to say, much harder to do. And then
yeah, because not everybody is going to get everything, so.
And the other thing is they do these in groups, and if this is going to be a semester-long project or a major project, not just some little thing, it's a major part of their grade. It's not just, 5 points project. It's like a major part of the grade. And developing a way to get you're assessing individuals as well as the groups is another issue. I know that that's a separate issue from research based, but if they do it in groups, and if you're going to grade it, and it's going to count significantly, you really have to get that under control. And these are two areas that I find problematic. So I was wondering if anyone else has had such experiences and how they handle it.
I can say, Nancy, when I did group work assessments, I actually leaned on some of my social science colleagues for how they use different assessments for group work. And one of the things I ended up adapting was having students evaluate each other in a constructive way, and so it was very structured in the types of questions I asked them about who contributed what, and all the feedback came directly to me, and then I collated that feedback for each student and made it more constructive, if that makes sense. It did take a lot of work, but I found my students were very honest about how much they contributed and how much others contributed, and they appreciated sort of this targeted, individualized feedback for group work. And it helped that if we had multiple projects, they could use that feedback on the next smaller project. So anyways, I would recommend, if you have a good relationship with other faculty, to see what they do in a lot of the social sciences, because I know they do a lot of group work. Anyways, just stuff I did.
We've done something like that. We actually have a course-based project, which is why I was asking the question about, I don't know if it actually counts, but we do have them fill out a self and peer evaluation of their group at the end. And we actually will adjust part of the score of the project based on that. If it's clear that there was someone who wasn't pulling their weight, as stated from both sides of it, from all members of the group. Or if someone did an exceptional amount of the work. But it usually shows up, they're very honest, and it does usually show up as like everyone acknowledges that that person worked harder than the others, or everyone acknowledges this person didn't really meet, including the person themselves, didn't really meet the deadlines or whatever it was, didn't do their part.
Yeah, I do something similar in my cure. Like I have the students evaluate each other at the end. There are rubrics out there for PBL, project-based learning assessments from the student side. So
Yeah, I know I have them. I have all of them. I have a lot.
yeah, so
I attended the project-based learning 3-day workshop, in Massachusetts that they offer. And this is a big part of it, but still, when you actually try to do it, it sounds easy, but it's not quite as easy as it sounds. But thank you.
But yeah, in terms of not being able to cover as much stuff with the project-based learning, yeah, I agree, but it's worth it to me for them to get the experience doing the projects.
and again, it could be something where the way the reason why I think a cure works in my class is because it's the third course of a 3-course sequence. Not every single institution requires that the students do, 3 physics courses. Secondly, we have a lab component in our Physics 1 course. If they look to transfer to Maryland, which is typically the school that requires the 3 physics courses, their Physics 1 course doesn't have a lab component. So I can take off, some of the labs that we're doing in the Physics 3 class, because they've already done 2 full lab-based courses already. So they've met the requirement for whatever is the lab component at Maryland. And they're still doing labs in my class as well as the cure. So, it kind of works in certain places. And I guess what it shows is that you pick and choose whichever of the format for doing undergraduate research would work, I think, for you. I mean, as an individual who's looking to do it.
Other questions or comments? I would like to put back up on the screen, if you haven't had a chance to do the evaluation or feedback for this workshop, this is both the URL and the QR code that you can use to fill out that form. Other questions or comments? If not, we want to thank our speakers, presenters for their presentations and giving us some ideas about some of the undergraduate research experiences that can happen at two-year colleges, and we appreciate that greatly. But if there's no other questions or comments, we're going to go ahead and end this session, and thank you for attending.